In our last example, we're going to find a basis for the null space and the range, and we'll also then be able to identify the nullity and the rank. This is going to be a little bit more involved process because we're actually finding a basis for the range. We're not finding a basis for the span of these column vectors. That would be a set of x's. We want a basis for the range, so we need a basis for the output values from this. Let's go after the null space first, though, because that's a little easier. So the basis for the null space as we know, is just going to come from setting this equal to 0. So the homogeneous system. That's what it means for the null space. Again, what we're looking for is a basis for the set of all x's, so the input values, if you will. So let's go ahead and do that. We can just do this by row refing. So do a little RREF on our matrix. And the resulting matrix from that looks like 1, 0, 0, 0, 1, 0, minus 3, 2, 0. And of course, we get our column of zeros on the right. And from that, then we want to go ahead and describe all of our vectors in terms of x1, x2, and x3. So this part's pretty similar to what we did before. Here I've got that x1 is equal to 3x3. The second row says that x2 is equal to minus 2x3. And the third one, of course, says that x3 is independent. And if we write that in vector form, it's a good thing we learned how to do that earlier. That means that x is going to come in the form x3 times the vector 3 minus 2, 1. So this is our vector that forms the basis, just that single vector. And the dimension then of the null space, or the nullity, is just equal to 1. So that part's pretty straightforward. It's the part where we go after the basis for the range that becomes a little bit more complicated. So let's look at how we can do that. And this, you'll remember, in order to describe our range, we need to write out our system. Let's get the right numbers in there. 2, 0, 5, 1, 3, 7. But now we want to know what the outputs look like. B1, B2, and B3. And again, the goal here is to first describe the range, and then we have to describe the range in terms of the vectors that we get. So let's go ahead and do that. And I've already done all the manual row refing on this particular problem, and the resulting condition for this turns out to be that 1/3 B3 minus 5/6 B1 minus 1/2 B2 is equal to 0. So that's the condition for this system to be consistent. And we can solve this out for B3 and have that B3 is equal to 5/2 B1 plus 3/2 B2. And now we just need to express this in vector form. So this means that B1 and B2 are free or independent variables. So that means that any vector in the range has to take the form B1, B2, again, those being independent variables, and then 5/2 B1 plus 3/2 B2. So now we just write it out in its vector form. So we get B1 times the vector 1, 0, 5 halves plus b2 times the vector 0, 1, 3 halves. And there you have the vector form. And if we wanted to just maybe have some slightly more convenient vectors to work with, we could also multiply these through, just so you know. We could make this maybe b1 times 2, 0, 5 plus b2 times 0, 2, 3. Once I have a couple of basis vectors, any scalar multiple of those basis vectors would still work just fine for us. In this case, we're just asked to determine what that basis is. We're not going to do anything with it, so the first set would be fine. But nonetheless, we now see that we've got a couple of nice vectors here. So this is our basis for the range of A. And again, we get these two vectors, 2, 0, 5 and 0, 2, 3. And we can also see then the dimension of the range, or the rank, of A is going to be equal to 2. And you'll remember that we had the nullity was equal to 1, and as our result that we had earlier in the lesson, we know that then the nullity of A plus the rank of A is supposed to be equal to n. In this case, nullity was 1, the rank was equal to 2, and that's 3, which does verify we were working with a 3 by 3 matrix, so n is 3. So here's our original. So here's our original matrix here. So that's how we can determine a basis for the null space and the range, and then consequently we can determine the nullity and the rank. Obviously we can figure out these two values without doing all of this work, but it's not uncommon for me to ask to find a basis for a null space and a range, so you should be prepared to do that.